So first I'm just going to create a quick cantilever beam model. So let's see, 2 degrees of freedom. Last video, what we did for our geometric transform is we just gave it a tag of 1. What I'm going to do here is be a little bit more specific and set a variable. So I'm just going to call it trans tag 1, and that means we can refer to it here, and it's a little easier to keep track of what means what. Let's put in a node at 0, 0, another node at the length of the beam. So let's move to the top, open up a new line, and we're going to set the length of the beam. Let's give it a length of 1 meter, 1000 millimeters. And then we're going to just create an element. Elastic beam column will be good. We're going to have a tag of 1. It's going to go from node 1 to node 2. We're going to have to give it an area. We're going to have to give it a second moment of area. And we're going to have to tell it the transformation tag, so we're going to give it trans tag. So now we're just going to have to define our area. Let's give it an area of 5,000, and we're going to have to set our modulus. Let's give that 200 kilonewtons per millimeter squared. Next, we're going to have to fix node 1, and we're going to fix it in all degrees of freedom. And now we're going to define our time series. As with the transformation tag, we're just going to set a time series tag, just give it the value of 1, and then we're going to put in a time series, and it's going to be a linear time series. And we just have to give it our time series tag. Next, we're going to set a pattern. Let's define a pattern tag. It's going to be number 1. And then we've got pattern. We're going to do a plain pattern, give it the pattern tag, give it our time series tag, and then we're going to define a load on node 2, which is going to be 0 in the x direction, p in the y direction, and 0 rotation. So again, we go to the top. We're going to set P, let's just say 10 kilonewtons. For now, it doesn't really matter what the numbers are. Now to define our analysis, so our constraints, our numberer, let's use the RCM numberer, our system. We want outbound SPD, algorithm, yeah, linear is good. Integrator is going to be the load control integrator, and we're going to give that a scale of 1, and then we tell it that our analysis is static. Then we're just going to analyze one-time step. Great, so once we've done this, let's return the node displacement at node 2 in the y direction. Let's see, trans tag. So I just made a typo. Here we go, just add that S in. What else have we got here? Okay, it looks like I've made a mistake on our beam column element. Forgotten to give it our second moment of area. So let's give it something like this. Great, and I've just forgotten to tell it to output. Great, here we go. So we've got 41 millimeters of displacement. Now, so we want to look at how we can use procedures to make this a little bit tidier, make it a little bit easier to extend later on. So what I'm going to do is, instead of defining the second moment of area like I have here, what I want to do is take, let's say we're using a rectangular beam, so we're going to take a base and a height, and we want it to output the second moment of area, which is base times height cubed divided by 12. So what we're going to do is use the proc keyword for procedure. We're going to name our procedure. So we can name it here, I'll just name it IZ. And it's going to take the arguments B and H, which is our base and height. And now we enter the body of the procedure. Here we're going to calculate the second moment of area based on the base and the height, and we return the value. So what we're going to do is return the expression base times h to the power of 3 divided by 12. If we want to just test this out, what we do is we call it, so we go puts IZ, and then using the base and the height, let's just say 10 and 10 just as a test. And we see over here, and this is correct. So if, for example, we wanted to use 50 and 100, great, it's going to change for us. So now, instead of setting this here, what we're going to do is we're going to set a base at 50 millimeters, and we're going to set our height to 100 millimeters. And down here, where we've declared I, we can just replace this with IZ, give it the base and the height value. So if we run that, we should still get the, no, we'll get a different answer because I'm using a different value. But so we're going to get 4 millimeters here. Great, so we have this procedure defined. Let's do the same thing for area. So instead of defining our area as a number, we're going to replace this with the procedure. We're going to call it A for area, and again it's going to take the base and the height, but this time a little bit simpler. We're just going to return base lowercase, times the height, and we get rid of this. Here where we've declared our area, we're changing that to the function call, so base and height. And after running that, we still have 4 millimeters, so it's exactly the same. The benefit of doing this, however, is instead of having to update our area and our second moment of area, for example, if we change beam types, we can change just the procedure, and then we don't have to change anything in here. What we can do now is we can actually do this whole analysis inside of a procedure, which is going to allow us a little bit more flexibility. It will allow us to call it multiple times and compare different results. So what we're going to do is, let's call it beam deflection, and our inputs are going to be the load, the length of the beam, the modulus of elasticity, and also our base and height of the beam. And then what we're going to do is we're going to come down here, put this whole thing inside the function, and then let me just tidy up the indentation. So now what we've done is we've put our whole analysis inside of a procedure. If we run now, we see that we have no output, and that's because we haven't actually called this beam deflection function. So we've told OpenSees that this is the procedure to follow, but we've never told it to actually do it. So what we can do is now call that function, so beam deflection. We're going to give it all of these values, so we can move all these down to the bottom. So we can give it our value P, our value L, our value E. We have to make sure we get this in the correct order. and we can see we get our 4 millimeters again. One thing that's better to do is instead of printing to output, it's better to return the value, and then we're going to print it out here. This just means if instead of printing it to the output, we want to redirect this value somewhere else, assign it to a variable, or do something else with it, this return is just a little bit better. And obviously we still get the 4 millimeters. We can actually tidy this up a little bit by using the format function, and we're just going to ask it to give us a float. So that's just going to tidy up, remove the white space, and only give us the number as a float. What this now allows us to do is we can use this to compare different things. So say we actually want to look at 20 kilonewtons, length of 1,000, 200, 50, 100. We can now compare. So if we double the load, obviously double the deflection. We can try out other things. So let's try double the length, and so on. So now we can call this analysis multiple times within the same script just by calling that procedure multiple times. Another important thing to note is we need to use this wipe keyword. If we don't use this wipe keyword, the first time we call it, it's going to create our nodes, our elements, and create our analysis. And then the second time we call it, these nodes, elements, and everything is still within the program. So there's already a node 1, but we're going to be, on the second call, we're going to try and create node 1 when 1 already exists, and OpenSees will just give us an error. I can just show you that now. So the first time it runs through, it does it fine, and the second time it tells us that there's already a node with tag 1 existing in the model. So we just have to make sure that we wipe the model before we run it a second time. Great, so that was just a quick little demo of how you can write procedures in TCL to help with your OpenSees models.